Hello and welcome to today's lesson on work done, which is part of the forces topic in GCSE Separate Science Physics. So in today's lesson we're going to try and understand how a resultant force causes work to be done. So if we've been successful and learnt in this lesson, we should be able to understand what work done is, calculate work done in power for both examination style questions and for experimental observations, which links into the following part of the GCSE Separate Science Physics specification of 4.5.2 work done in energy transfer, which is found in the forces topic. Now previously we've considered the impact of an object having a resultant force. A resultant force causes an object to accelerate in the direction of the resultant force, but a resultant force can also cause energy to change between different energy stores. So for example, an object can change its energy store from a gravitational potential energy store to a kinetic energy store with a resultant force being applied to the object. This is called work done. Now technically a resultant force causes a change in energy store without the need for a wave such as light. So when a force moves an object through a distance, energy is transferred and work is done on the object. This means that work done is another name for energy being transferred between different forms or stores. Now in many examination questions they can ask you to calculate the energy transferred and then the work done. Don't be tricked because these are actually the same value. So when a resultant force causes an object to move through a distance, work is done on the object. So we can say a resultant force does work on an object when the force causes a displacement of the object. And we can calculate this with the following equation. Work done in joules is equal to the resultant force in newtons times by the distance moved in the direction of the force in meters. So 1 joule of work is done when a force of 1 newton causes a displacement of 1 meter. So we can say that 1 joule is equal to 1 newton meter, or 5 joules is equal to 5 newton meters, or 11 joules is equal to 11 newton meters. Now it's important to note that with this equation we've got to consider the actual idea of distance. It's the distance moved in the direction of the force. So work can be done if the object is displaced in the direction of the resultant force. This means if an object does not move in the direction of the resultant force, no work is done. Now like we said previously, we can define 1 joule as the energy needed to move 1 newton of weight by 1 meter in the direction of the force, because if work done is equal to force times by distance moved in the direction of the force, 1 joule is equal to 1 newton times by 1 meter. So therefore we can define 1 joule as the energy needed to move 1 newton of weight by 1 meter in the direction of the force. So let's look at an example of calculating work done. So in this case, what's the work done due to gravity? Well, work done is equal to force times by distance moved in the direction of the force. So what's our force? Well, it's our mass times by our strength of gravity to give us the weight. So it's 10 times by 9.81 times by the distance moved in the direction of the force, which is vertical, so times by 2, so it's 196 joules. So this is the work done due to the gravitational force, but this can only happen when the object is moving in the vertical, as the direction of the gravitational force is in the vertical. So if we look at the following example now, what's the work done due to gravity? Well, again, the force is going to be 10 times by 9.81 to work out the weight of the object, but now our distance moved in the direction of gravity, which is the vertical, is 0 because it's only moving in the horizontal. So in this example, the work done due to gravity is 0 joules. There is no work done due to gravity as the object is not moving in the direction of the gravitational force. So it is moving in the horizontal though, so there is some work done on the object, but it's due to another force, a force working in the horizontal, as that's the direction the object is moving in. Now, a common example of where work done is carried out in the direction of a force is a particle accelerator. So in a particle accelerator, there tends to be two forces found in the accelerator, the magnetic force and the electrical force. Now, you'll notice that the electrical force is the force which does the work because that is in the direction of the particle movement. So therefore, because the particles are moving a distance in the direction of the electrical force is doing the work. The magnetic force is not doing the work in this example because our object is not moving in the direction of the magnetic force. Now, when work is done against friction, this can cause heat energy to be transferred to the internal energy of the surroundings. This is because friction can act as a resultant force which can make the energy change stores in the process. Now, friction can cause some of the energy to be transferred to the thermal energy stores. So this will cause the overall temperature of the object to increase, and this will eventually dissipate energy to the internal energy of the surroundings. Now, this is shown by rubbing your hands together to keep warm. As you move your hands together, there is a frictional force. So when work is done to overcome this frictional force, some of the energy is transferred to the thermal energy store of your hands, which will keep your hands warm. Now, we can also consider this concept in terms of a stopping vehicle. So if we consider a vehicle which is moving due to the thrust force, the vehicle is brought to a stop when the brakes of a vehicle are applied. Okay, so a frictional force is applied to its wheel. Now, work is done by the frictional force between the brakes and the wheel. So this transfers energy from the kinetic energy store of the car to the thermal energy store of the brakes. So this brings the vehicle to a stop, okay, but it also increases the temperature of the brakes because work is being done to overcome the frictional force. So let's summarize what we've learned in today's lesson. When a force causes an object to move through a distance, work is done on the object. So a force does work on an object when the force causes a displacement of the object. So work done can be calculated with the equation force times by distance moved along the direction or the line of action of the force. 1 joule of work is done when a force of 1 Newton causes a displacement of 1 meter. So 1 joule is equal to 1 Newton meter. Now, you should be able to describe the energy transfer involved when work is done, and you should be able to convert between Newton meters and joules and understand that work done against the frictional forces acting on an object causes a rise in the temperature of the object. So if we've been successful and learnt in this lesson, we should be able to understand what work done is, calculate work done and power for examination style questions, and looking at the same process with more practical applications. So thank you very much for watching this particular lesson on work done, which is part of the forces topic in GCSE Separate Science Physics. Thank you very much for watching and have a lovely day.